Hello everybody. Today we are going to continue talking about factoring polynomials. Specifically, we want to cover the methods to factor a quadratic trinomial. Last class we have introduced the shortcut method. We use the shortcut method to factor a quadratic trinomial with leading coefficient 1. Hello White. Thank you for saying hi. Let me get our note. And we're going to continue talking about shortcut method, all right? We use the shortcut method when we need to factor a quadratic trinomial with the leading coefficient 1. And we covered the first question on Monday. Let's look at the second question. The second question, we have x squared plus 5x plus 6. Compare this trinomial with the quadratic trinomial with the standard form of the quadratic trinomial, ax squared plus bx plus c. And we can tell the given trinomial is a quadratic trinomial. Quadratic in algebra means degree 2. And we have a, the leading coefficient equals 1, b, the coefficient of x equals 5, c, the constant equals 6. So the shortcut method applies here. To apply shortcut method, we go ahead to look for two integers whose product is c, 6 here, and whose addition is b, 5 in this case. This part is something you need to memorize. How do we apply shortcut method? Once we identify the given polynomial is a quadratic trinomial with the leading coefficient 1, we go straight to find the two integers, multiply to c, add up to b. We have to memorize that. The two integers we are looking for, multiply to c, add up to b. Think about if the two integers we are looking for multiply to positive 6. Does that mean the two integers have the same sign, either both positive or both negative, right? Since the two integers add up to positive 5, the two integers must be both positive because the sum of two negative numbers is still negative. If you look at your note, the four conclusions we went over on Monday, the first conclusion corresponds to this question. Case 1 corresponds to this question. Let me go back. Case 1 we learned on Monday. If two integers multiply to positive and add up to positive, then the two integers are both positive. We have spent time to understand, make sense of this conclusion already on Monday. I hope you still remember, and I hope you still understand, or it still makes sense to you. If the two integers multiply to positive, they must have the same sign. They must be positive both because their addition is positive. So this question, we have both two integers we are looking for are positive. And which two positive numbers? We are going to factor the absolute value of c. So this part is also need to memorize. We need to factor the absolute value of c. In this case is 6. How do we factor? We start from 1. 6 equals 1 times 6. And try 2. 6 equals 2 times 3. And try 3. 3 times 2, 2 times 3 is the same thing, so we don't have to write it again. And 4 does not go into 6 completely, so we do not write 4. 5 does not go into 6 completely either, so we do not have 5. And 6, we have a 6 already here. So the only way to factor 6 is 1 times 6 and 2 times 3. Remember, both of the two integers are positive, so we are going to place a positive sign above the first factor and the positive sign above the second factor as well. And now let's go over all the possibilities, all the possible cases, options. Could the two integers be positive 6 and positive 1? They do multiply to 6. They do multiply to 6. However, they do not add up to 5. The two integers we are looking for must add up to 5. 1 and 6 add up to 7. So no, that's not the case we are looking for. Then we have one more thing, one more option, 2 and 3. Positive 2 and positive 3. Do they multiply to 6 and add up to 5? They do, right? 2 times 3 is 6. 2 plus 3 is 5. And that's the two integers. Satisfy the... Just join start. Okay. Remind me later. I'm going to mark the attendance later. So we have Dakota join us. So the two integers are 2 and 3. All right. Let me repeat what have happened here. We identify this polynomial is a quadratic trinomial. Degree is 2, 3 terms, quadratic trinomial, and leading coefficient is 1. Coefficient of x is 5. The value of b is 5. Constant is 6. The value of c is 6. Then we know the shortcut method applies. Once we know the shortcut method applies, we go ahead to find two integers, multiply to 6, add up to 5. Multiply to c, add up to b. That's something, again, you need to memorize. We go ahead to find the integer whose product equals c, whose sum equals b. In this case, c is 6, b is 5. And we determine the sign for the two integers first, and then factor absolute value of c, and we only have two ways to factor 6. And we know the two integers must be positive, so we go through two options, either 1 and 6 or 2 and 3, and we know 2 and 3 are the two integers, satisfy both conditions. Because 2 times 3 is 6, 2 plus 3 is 5. So we found the two integers, and how do we factor this trinomial? This trinomial is x squared plus 5x plus 6. Once we got the two integers, we can write the factorization of the trinomial as parentheses times parentheses. In the first parentheses, we have x plus a number. In the second parentheses, we have x plus another number. And the two numbers are the two integers we have just found. By the way, the order doesn't matter, okay? If I put 3 here, 2 here, it doesn't make a difference. Very important. 2 and 3, the two integers, you can double check once you have your proposed factorization. 2 and 3 must multiply to 6, value of c. 2 and 3 must add up to 5, coefficient of x. So that is the shortcut method. This is the shortcut method. If I check the answer, let me check the answer. Let's see if x plus 2 times x plus 3 equals x squared plus 5x plus 6. Let's use the box method. We have x plus 2 times x plus 3. So you know what? I want to keep the color. X plus 2, x plus 3. There's a purpose I'm doing this, okay? I'm reversing the process. I want you to see why. So the box is going to have 2 by 2, 4 cells. And I place one on the side, x plus 2, the other above, x plus 3. And then we are going to multiply. X times x is x squared. And 3 times x, 3x. 2 times x, 2 black x. And 2 times 3, 6. I know it's 6, but allow me to write it as 2 times 3 here. 2 times 3 here. And the result would be, remember the pattern, diagonal pattern. And this is the, oh, I changed the color. I don't want to change the color, so let me change this as yellow. Yellow does not cover the red. Okay, and then this one, this, I don't want to color the red. Okay, so we have x squared plus, as you can see, we have 3x. 3x and 2x, they are like terms, right? We can combine them. 3x plus 2x is 5x. I know it's 5x, but let me write that as 3 plus 2, or 2 plus 3 times x. And then plus 2 times 3. Okay, so what I want to show you is the two integers in the parentheses, in the factorization, they multiply to c, the constant term. They add up to the coefficient of x. That's what I want to show you. And that's the foundation, actually, the reasoning why the shortcut method applies. The two integers. So any quadratic trinomial with leading coefficient 1 can be factored in this format. The pattern, the format of the factorization is always the same thing. X plus number times x plus another number. The factorization of a quadratic trinomial with a leading coefficient 1 always equal to a multiplication of two prime binomials. The two binomials have the structure x plus number. No coefficient of x. Coefficient of x is 1 here. Coefficient of x here is also 1. So x plus number times x plus another number. And the two numbers must multiply to the constant term and add up to the coefficient of x. And let me know, does that make a little bit more sense compared with Monday? The timing on Monday wasn't perfect because we just started the shortcut method and then we ran out of time. Any feedback, please? Basically, I'm trying to explain why the two integers have to multiply to c, add up to b. You can try any type of thing, is the same thing, same pattern. It makes more sense. Okay, awesome. Thank you, Belle. Thank you, Jill. Okay. Let's continue though. So that's number 2, right? Let me write a result here. X squared plus 5x plus 6 equals x plus 2 times x plus 3, or x plus 3 times x plus 2. Really doesn't matter the order. And number 3 is x squared plus 7x minus 8. X squared plus 7x minus 8. I need to erase something that have more space. Let me erase those. If you watch the video, the note is there. You can just take a screenshot, something like that. Number 3. We have x squared plus 7x minus 8. Compare this trinomial with the standard form of a quadratic trinomial with a leading coefficient 1, quadratic trinomial formula. We know this is a quadratic trinomial. Degree is 2, 3 terms. And also we can identify the leading coefficient is 1, coefficient of x is 7, constant term is negative 8. Remember, we are looking for two integers. Multiply to c, in this case negative 8, add up to b, in this case is 7. All right, so we are looking for two integers, multiply to negative, add up to positive. We are looking for two integers, multiply to negative, add up to positive. I would always determine the signs for the two integers first. That's the reason we have those four conclusions understood on Monday. Look at the four cases. Which one is the one the two integers multiply to negative, add up to positive? Let me see. Multiply to negative, add up to positive. Is a case number 3, right? Yeah, exactly. Thank you, Amanda. Case number 3. That means, as you can see, if two integers multiply to negative and add up to positive, then the two integers have opposite sign, and then the positive number has bigger absolute value. So this is how do I mark the conclusion. So one is positive, the other is negative, and the positive number has a bigger absolute value. Negative number has a smaller absolute value. So I put a bigger question mark to remind myself the positive number has a bigger absolute value. The smaller size question mark indicate the negative number has a smaller absolute value. Okay, so now we are going to factor the absolute value of C, which is 8. Do not worry about the sign, just do the absolute value. So 8 equals, remember how do we factor? We start from 1. A equals 1 times 2. Sorry, 1 times 8, I'm sorry. 1 times 8. Also could be 2 times 4. 3 doesn't work. 4 is here already. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 is here already. So only 2 options. And remember, the positive number has a bigger absolute value. Negative number has a smaller absolute value. So for each pair, the two numbers, the positive number has bigger absolute value. Negative number has a smaller absolute value. That's the reason I place a positive sign above the second factor, a negative sign above the first factor. So let's give it a try. We have two options, either -1, +8, or -2, +4. -1, +8 multiplied to -8. And their addition is what? Their addition is 7, right? Actually, this is the answer. And this doesn't work because even although -2 and 4 multiply to -8, their addition is 2, not 7. We needed the addition as 7. So the second option doesn't work. Has to be the first one. We have -1, +8. -1, +8. So now we know -1, +8. They multiply to -8, add up to 7. Shortcut method. Once we have those two integers found, we are able to find the solution, the factorization right away. Parentheses times parentheses. In the parentheses, we have x plus number, and the two numbers are going to be -1, +8. Or I can write the result as x plus 8 times x minus 1. The order of the two factors doesn't matter. Does that make sense? Again, I would always double check. -1, +8, multiply to -8, the constant. -1, +8, add up to 7, the coefficient of x. Am I clear about this question? Shortcut method is very, very important, guys. If you don't understand this process, you cannot pass this chapter. So you have to understand it. All right, thank you. Thank you for the feedback response. Let's continue. We have tons of similar questions to practice. So that's number 3. Let me write down the answer. The result for number 3 equals x minus 1 times x plus 8. All right. I'm going to erase this part. If you watch the video, you would have the note. And also, I think you can take a screenshot while you watch the. I mean, right now, when we are like doing the online live. Number 4. Question number 4. We have x squared minus 13x plus 36. Compare that with the formula, the standard form of a quadratic trinomial. And we know the given polynomial is a quadratic trinomial, degree 2, 3 terms. And we also identify the values for a, b, and c. A is 1, b is negative 13, c is 36. Since a equals 1, we know the shortcut method gonna apply, right? Shortcut method gonna apply. So we going to go ahead to find the two integers, multiply to c, add up to b. I explained why. Why do we need to find the two integers, multiply to c, add up to b? Earlier when I reverse, when I reverse the process for the second question, I showed you why the two integers must multiply to c, add up to b. That's the pattern. Okay, let's start it. In this case, we are looking for two integers, multiply to positive 36 and add up to negative 13. So I want you to help me to determine the signs for the two integers. Yeah, anybody can tell me the signs for the two integers. Negatives. Jill, you mean both of them, both of the two integers are negative. Exactly, it's correct. Yeah, they are both negative. Very good. They have to be both negative. They have to be both negative because their addition is negative and their multiplication is positive. Means they have to have the same sign. And they cannot be both positive because the addition is negative. Very good. And let's figure out which two negative integers satisfy both of the two conditions. We are going to factor 36. Remember, how do we factor 36? I need more space, so I'm going to write this part on the side, 36. 36 could be 1 times 36. You can try use your calculator if you lost if you feel like it's struggling calculation. Just use a calculator. 36 equals 1 times 36. Try 2 times 18, right? I encourage you use calculator because I do not want you to lose a point because of the calculation error. And we try 3. 3 times 12 is 36. And try 4. 4 times 9 is 36. Try 5. 5 doesn't work. Try 6. 6 times 6 is 36. And you will see 7 doesn't work. 8 doesn't work. 9, we have 9 already. 10 doesn't work. So when you see we are going to go up, like from here to here, and that means we are through. We have all the possible factorizations for 36. So that's all the possible ways to factor 36 as the multiplication of two integers. Remember, the two integers we are looking for must be both negative, right? So let's try. We have 1, 2, 3, 4, 5 options. Would -1 and -36 satisfy both conditions? They multiply to 36, but they do not add up to -13, right? -1, -36 add up to -37, too much. And we try -2, -18. -2, -18 add up to -20, doesn't work. We want a -13. And we try this one, -3, -12, they add up to -15. Very close, but no. And then we try this one. -4, -9. Guys, -4, -9, they add up to 13, right? 94 times -9 is a positive 36. 94 plus -9 is -13. So the two integers we are looking for are 94 and -9. With that found, we are able to write the original given polynomial as parentheses times parentheses. In the parentheses, we have x minus 4 and x minus 9. And that's the answer. Always double check. 94, 99 multiplied to c. 94, 99 add up to b. Is that clear, guys? Very good. Perfect. Let me write the answer for number 4. X minus 4, x minus 9. Okay, number 5 is yours. Number 5 is yours. I'll let you struggle a little bit, just a little bit. Number 5, x squared plus x plus 2. Any progress? Number 5, x squared plus x plus 2. We identify A is 1, B is 1, C is 2. So we should be able to, so the shortcut method applies. So we're going to go ahead to find the two integers, multiply to C, add up to B. Let's see, how do we find those two integers? I would determine the sign first. Question: can you help me to decide what are the signs for the two integers? They multiply to positive, add up to positive. They have to be both positives. Do you agree? They have to be both positive. Very important. Yeah, they have to be both positive. Let me show you the first case. If two integers multiply to positive and add up to positive, then the two integers must be both positive. Okay? They cannot be one positive, one negative. Otherwise, their multiplication would not be positive. They have to be both positive. Do you agree, Joe? The two integers must be both positive. Yes, they have to be both positive. No doubt on that. All right, so which two positive numbers? Let's factor 2. The only way we factor 2 is 1 times 2 because it's prime. The only way we can factor 2 is 1 times 2. And the two integers have to be both positive. So that means the only option we have is a positive 1 and a positive 2. They do multiply to 2, however, they do not add up to 1. We are looking for two integers add up to 1, right? But 1 and 2, they add up to 3. So what does that mean? That means the only possible option does not work. It doesn't mean the shortcut method does not apply here. Shortcut method applies. Shortcut method helps us to find out the original polynomial actually is not factorable. Sorry about that. Maybe make you feel struggle a little bit because I cannot find the two integers satisfy the two conditions. That's fine, because the two integers that satisfy the two conditions do not exist. Yeah, they do not exist. The only option we have, positive 1, positive 2, doesn't work. That means the original given polynomial is not factorable, or we can say the original polynomial is prime. When a polynomial is not factorable, we say the polynomial is prime. By the way, we factor polynomial in this course. When we factor polynomials, we are factoring those polynomials in a rational number set. We are not factoring them in the real number set or complex number set. In the future, if you go when you go to upper level mathematics, you might need to learn this again, but you are factoring them in a extended number set, maybe real number set or complex number set, and that would be different. You would learn more methods. But in this case, we only learn the methods that I'm going to give you, and we are factoring those polynomials in a rational number set. And in a rational number set, this trinomial is prime, is not factorable. How do we know? The shortcut method helps us figure out. The only option doesn't work, so prime. So let me write it down. This polynomial is not factorable or prime. Okay, guys, please try number 6. Please try number 6. Not factorable, yeah. Thank you, very good, exactly. That one is not factorable. Let's look at it together. Number 6, we have x squared minus x minus 1. A is 1, B is -1, C is -1. We need two integers multiply to C, add up to B. So if the two integers need to multiply to negative, add up to negative, the two integers must have opposite sign, right? Very important. We need to determine their sign. They must have opposite sign, and the negative number has a bigger absolute value. The positive number has a smaller absolute value. And then we are going to factor the absolute value of C. Absolute value of C is 1, and the only way to factor 1 is 1 times 1. And the two integers must have opposite sign. One is positive, the other is negative. And the only option doesn't work. because the positive 1, negative 1 add up to 0. They do not add up to negative 1. So number 6, the polynomial is also not factorable. Good job, guys. So far, we have seen this many cases, okay? Number 1, two integers multiply to negative, add up to negative. I think that is the case number 4. The two integers we are looking for multiply to negative, add up to negative. And question number 2, the two numbers multiply to positive, add up to positive, so case number 1. The 4 conclusions we will know on Monday. Number 3, the two integers we are looking for multiply to negative, add up to positive, that's case number 3. Number 4, the two integers multiply to multiply to positive, add up to negative, so that's case number 2. The first 4 questions corresponding to the 4 cases, 1 for each. And then number 5, number 6 are the case that the polynomial, the quadratic trinomial, not factorable. Okay, let's see number 7. You will see some more little like a different version of this topic, like shortcut method. Let's see number 7. Number 7 is a quadratic trinomial because the degree is 2 and it has 3 terms and is in the standard form. And the leading coefficient is -1. So number 7 is to show you what do we do when the leading coefficient is -1. When the leading coefficient is -1, how do we factor the polynomial? This is what we do. Number 7, when we try to factor a quadratic trinomial and the leading coefficient is -1, what do we need to do is to factor out -1. First, GCF of the 3 terms is 1, as we can tell, but it's negative, so we have to factor -1 out. We do not like the leading coefficient to be negative. So let me repeat what I said earlier. Number 7 is to show you what do we do, how do we factor the polynomial when the leading coefficient of the polynomial is -1. So what we do first is we factor out -1. And please let me know if we factor out -1, what's going to be in the parentheses? What's going to be in the parentheses? If we factor -1 out, what's going to be in the parentheses? You can try the methods we learned on Monday. Use term 1, original term 1 to over GCF. So 91 here actually is a negative GCF. So original term 1 over 91 plus original term 2 over 91. And then plus original term 3 over 91. Or think about the reverse. Think about the reverse of distributive property. So what we should have in the parentheses is x squared plus 5x plus 6. Do you agree? Because we are factoring out -1, so all the 3 terms going to change to their opposites in the parentheses. And you can reverse to double check. -1 times x squared, -x squared. -1 times 5x, -5x. -1 times 6, -6. Do you agree, guys? Very good. So again, if the leading coefficient is a -1, we need to factor out -1. And normally we don't really write the 1 out, just leave a negative sign here. And now let's factor x squared plus 5x plus 6. I give you 1 minute for that. Now let's factor the blue trinomial x squared plus 5x plus 6. Firstly, we factor -1 out or negative sign out. Secondly, we're going to factor x squared plus 5x plus 6. When we factor x squared plus 5x plus 6, the shortcut method applies because the leading coefficient is 1. Shortcut method applies when the quadratic trinomial has leading coefficient 1. Now you can apply the shortcut method. And let me know what you have. X squared plus 5x plus 6. We need to find the two integers, multiply to 6, add up to 5. Awesome. Very good. X plus 2 times x plus 3. Awesome. And don't forget we have a negative sign in front of it. So the answer is a negative parentheses x plus 2 times parentheses x plus 3. And this is the final answer. This is the final answer. Do not forget we have a negative sign in front of it. Awesome, very good. Yeah, very good. So number 7, the purpose of number 7 is to show you again, to show you what do we do if the leading coefficient is -1. Just factor the negative sign out and then apply the shortcut method. Let's move to number 8. There's a purpose for number 8 here, all right? Let's look at this polynomial. 3x squared minus 27x plus 4. Plus 42. Plus 42. 3x squared minus 27x plus 42. And this question, there's a purpose for this question, is to show you sometimes if you to show you the first step, to show you if you see the leading coefficient of the quadratic trinomial is not 1, do not rush to apply other method. In fact, this problem, the shortcut method still applies. You just need to get ready for the shortcut method. How do you get ready? You factor GCF out. You might remember on Monday we have a rule. It says whenever we need to factor polynomial, the first thing to do is to observe and identify the GCF of all the terms in the polynomial, and then factor it out. Look at our trinomial. We have 3x squared minus 27x plus 42. Anybody can help me to identify the GCF of the 3 terms? I don't think it's 1. The reason we have not done that yet in the previous question is because the GCF of the previous polynomials is 1. So we kind of skip the step. But in this case, look at those numbers. 3, 27, 42. What's the GCF? Yes, 3. Very good. Perfect. The GCF is 3. So we're going to firstly factor 3 out. And let me know what you have in the parentheses. We have 1, 9, 12. Let's see. 1, 9, 12. 12. Double check, Joe. Maybe it's not 14. No, it's not 14. It is 14. Yeah, it is 14. Okay. So the in the parentheses, I'm gonna write that as blue. We're gonna have x squared minus 9x plus 14. If you are not sure, guys, reverse it, right? Let's try to reverse it. 3 times x squared, 3x squared. 3 times negative 9x, negative 27x. 3 times 14, 3 times 14 is 42. So the blue polynomial is correct in the parentheses. And in your scratch paper, you can do this. So now I'm gonna factor x squared minus 9x plus 14 on my scratch paper, right? X squared minus 9x plus 14. That polynomial has coefficient 1, so we can apply the shortcut method. The shortcut method applies here. Guys, I'll give you a couple minutes. Help me to factor x squared minus 9x plus 14. We need to find the two integers. They multiply to 14, add up to negative 9. Which two numbers multiply to 14, add up to negative 9? Negative 2, negative 7. Exactly. Awesome. Thank you, Joe. Negative 2, negative 7 time, multiply to 14 and add up to negative 9. Perfect. Very good. So we have negative 2, negative 7 here. And we're not done yet. So the final answer for number 8 would be 3 times, don't forget the 3 here, 3 times x minus 2 times x minus 7. And now we are through, we're complete. Any questions about number 8? Again, number 8 is the purpose we have the question number 8 here is to show you that when the leading coefficient is not 1, does not necessarily mean the shortcut method doesn't apply. You might consider factor it out if the leading coefficient is GCF. In this case, the leading coefficient is not 1, but it's the GCF of all the 3 terms. So we are able to factor it out. After we factor the leading coefficient out, the trinomial in the parentheses has coefficient 1. So the shortcut method applies as well. Any questions, guys? Awesome. So let's continue. Number 9. Number 9 has a purpose here. The trinomial is negative 2x squared minus 16x minus 30. I have this question example include because I want to show you what do we do if the leading coefficient is a negative GCF. In this case, the quadratic trinomial has a leading coefficient negative 2. And negative 2 actually is the negative GCF of the 3 terms. As you can see, 2, 16, 30, their GCF is 2, but the leading coefficient is also negative. We do not want a negative leading coefficient. So we should factor negative 2 out. And negative 2 here is the negative GCF. I have a purpose for that. And after we factor negative 2, in the parentheses, we're going to have x squared plus 8x plus 15. If I'm not sure, I can double check, right? Negative 2 times x squared, negative 2x squared. negative 2 times 8x, negative 16x, negative 2 times 15, negative 30. Okay, I will let you to help me to factor this blue trinomial in the parentheses, x squared plus 8x plus 15. Shortcut method applies here as well, because the blue trinomial has the leading coefficient 1. We need to find the two integers, multiply to 15, add up to 8. Multiply to 15, add up to 8. Exactly. Thank you, Dakota. 3 and 5. They add up to 8. They multiply to 15. 3 and 5. Very good. So now let's put it back. The result would be negative 2. Don't forget the negative 2 in front of the parentheses. Times x plus 3. And then times x plus 5. And that's it. The final answer is negative 2 times parentheses x plus 3 times x plus 5. Very good. Thank you, Jill. That's correct. Again, there are purpose for those questions, all right? The first 4 questions correspond to the 4 cases. 5 and 6, they are not factorable. Number 7 is to show us what to do if the leading coefficient is negative 1. Number 8 is to show us what to do if the leading coefficient is the GCF. You just need to factor it out. And number 9 is to show us what to do if the leading coefficient is a negative GCF. Then you just factor the negative GCF out. Double check after you factor the GCF or negative GCF out. Double check by using the distributive property. Okay, and then you apply shortcut method. I would recommend that you look at those questions more times because they are very good questions. We do have the negative 2 on the outside. Yes, exactly. You're right, Joe. We do have negative 2 on the outside. So the shortcut method basically just a part of the solution. We do have negative 2 in front of it. We factor the blue trinomial and we put it back and multiply the negative 2. Very good. All right, I think we are done with the shortcut method. I'm not saying we are done today. We're not done yet. We are done with the shortcut method for now. So we should know how to factor a polynomial, quadratic trinomial with leading coefficient 1. Here the question is, what if the leading coefficient is not 1? Next up, what if the leading coefficient of a quadratic trinomial is different from 1, and we are not able to factor it out? It's not like number 8, even the leading coefficient is not 1, but we are able to factor it out. Or 9, even the leading coefficient is not 1, we are able to factor it out. What if it's not 1, and also we cannot factor it out? We're going to learn a new method, okay? The new method is called slide, divide, slide method. As you can see from the name of the method, we are going to have 3 parts in the process, or in the 3 steps in the solution. Okay, let me show you how do we do that. Number 1, 6x squared minus 13x plus 6. If I write the formula of the standard form of a quadratic trinomial right under, and you can compare, and the given trinomial is a quadratic trinomial, degree 2. And then we also can write the ABC, right? A is 6, B is negative 13, C equals 6. So the leading coefficient is not 1. Can we factor 6 out? We should consider if it's not 1, we should consider can we factor it out? Or you can ask yourself the question, what's the GCF of the 3 terms? What is the GCF of the 3 terms? What's the GCF of the 3 terms? Six, 13, and 6. Yeah, thank you, Amanda. Nothing can be factored out. So that's why shortcut method, like directly application of shortcut method doesn't work anymore. So we're gonna use slide divide slide. Let me show you how. We have 6. So we agree this is a quadratic trinomial with leading coefficient different from 1. And we don't like this leading coefficient, okay? We don't want it. We wish that leading coefficient was 1. So we can just move it away, slide it away to create a new trinomial. Create a new trinomial with the leading coefficient 1. How do we get that done? We slide. So the first step, slide, right? We simply slide 6 away to multiply with the constant. So the 6 in front of x squared is slide away, so there's nothing in front of x squared anymore. And copy the middle term, negative 13x. And then remember, we slide 6 away to multiply with the c. So we do not have a 6 here. Instead, we have 36. Because 6 times 6 is 36. And let me know, am I clear about the first step, slide? If the leading coefficient is different from 1, we slide it away. Slide 6 away, then there's nothing in front of x squared. And the constant would become the leading coefficient multiplied with the constant term. Okay, awesome. Thank you, Belle. And the blue trinomial, x squared minus 13x plus 36, has a leading coefficient 1. So you still have to use a shortcut. Shortcut method is a critical step of this solution, of slide divide slide. So basically, we have a shortcut here. We have a shortcut here. Okay, I'll give you a little time. Help me to factor this blue trinomial. Help me to factor the blue trinomial. We are looking for 2 integers, multiply to 36, add up to negative 13. Which 2 integers multiply to 36, add up to negative 13? Awesome. Very good. You are right, Joe. So we have x minus 4, x minus 9. Okay? So that's slide. And then we did a shortcut. We factored the new trinomial. So now we're going to divide, all right? We're going to divide. Yeah, we're going to divide. Divide what by what? Divide the two integers you just found. I wrote it in red by the original leading coefficient. The original leading coefficient is 6, right? The one we slid away. Original leading coefficient is 6. So I'm going to use a different color. Use black here. Divide by 6. Divide by 6. That's the second step, divide. Divide the two integers in red by 6. And then we simplify. Right after we divide, we need to simplify. Right after we divide, we need to simplify. We have negative 4 over 6. Simplify as negative 2 over 3. And then negative 9 over 6. Simplify as 3 over 2. So that's divide. And now we move to the last step, slide. After we divide and simplify, if we still have denominators here in the fraction, we are going to slide the denominator in front of x in the same parentheses, like that. The first parentheses, we have x minus 2 over 3. The denominator is 3, not 1, is 3. So we have to slide a 3 in front of x. We have 3x minus 2. And in the second parentheses, we slide a 2 in front of x. We have 2x minus 3. And this is the final answer. Guys, give me 2 minutes. Excuse me for 2 minutes, okay? Sorry about that. I just need to check my baby, make sure she's fine. Okay, so that's slide divide slide method. I have a video, and in the video I have 3 different methods to factor a quadratic trinomial with leading coefficient different from 1. And the second method is this slide divide slide. And in the past, I tend to introduce different methods. But recent years, I only teach you one good method. I think one good method would be enough for us to pass the exam. And I choose slide divide slide because it's pretty doable and very short steps. Doesn't have many steps. Slide divide slide is also easy to remember. Okay, guys. So let me do the second one. Let's do one more time. Number 2, 3x squared plus 4x minus 4. Firstly, let's double check what's GCF. What's the GCF of this trinomial? 3x squared plus 4x minus 4. 3, 4, 4 is 1, exactly. Thank you, Jill. So there's nothing we can factor out. We would have to deal with the leading coefficient. So this is how do we get rid of leading coefficient. We are going to slide it away to multiply with the constant. And we are going to create a new trinomial. That is x squared plus 4x. So the middle term, 4x, remains the same. And the constant term going to change because we slide the leading coefficient 3 to multiply with the constant. 3 times 94, 12. So this is the trinomial we created. And give you a little time, help me to factor this trinomial using shortcut. Using shortcut to factor x squared plus 4x minus 12, we need to find two integers, multiply to negative 12, add up to 4. Those two integers must have opposite sign. Negative 96, positive, yeah, positive 2. Very good. Oh, hold on, no. So always double check. Is it positive 6, negative 2? You can modify, right? Positive 6, negative 2. Positive 6, negative 2 times multiply to negative 12, add up to 4. Yeah. All right, and then what do? We divide, right? We divide two numbers in red. Only the two numbers in red, not x. Do not include x. Only the two numbers in red. Divide them by the original leading coefficient. The original leading coefficient is 3. Original leading coefficient is 3. So we divided the red 6 by 3 and here negative 2 by 3. And then we simplify. Right after we divide, we simplify. 6 over 3 is 2. 6 over 3 is 2. And negative 2 over 3 is already simplified. So in the second parentheses, we just have x minus 2 over 3. And since in the first parentheses, we do not have a denominator with the constant, so we do not have to slide for that parentheses. We only need to slide this denominator in front of x. And the final answer is going to be x plus 2 times 3x minus 2. And that's it. Let me know, is that clear? Slide first, and you would have a quadratic trinomial with a leading coefficient 1, and your shortcut method to factor it, and then divide. Yeah, ask yourself, divide what by what? Divide the two integers you just found from the shortcut by the original leading coefficient. And of course, please remember to simplify the two fractions. If after we simplify, we still have denominators, we slide it back in front of x, and we have the final result. And you can always use the box method to multiply those two binomial to see if you have original quadratic trinomial. Any questions about number 2? All right, try number 3 yourself. Try number 3 yourself. Nine x squared plus 64x plus 7. Bell has 9x plus 1, x plus 7. Well, I have to do it first. Very fast. Let me double check. So we slide this to create a new trinomial. X squared plus 64x 63, and then we shortcut method to factor it, and we have 63 plus 1, and then we divide the original leading coefficient, which is 9, and we simplify, and we slide back, and we have x plus 7 times 9x plus 1, or 9x plus 1 times x plus 7, it doesn't matter the order, 9x plus 1, x plus 7. Awesome. Thank you, Belle. That's correct. Very good. Any question about number 3? Do you have the same result? I think actually the challenging part is still shortcut. If you grasp shortcut very well, the slide divide slide is very easy to do. Okay, if you understand number 3, please try number 4. Number 4, 2x squared minus 9x minus 5. And let me know if anyone want to see the video that I mentioned earlier that has all the 3 methods to factor a quadratic trinomial with leading coefficient different from 1. And let me see what's the answer supposed to be. Is x minus 5, 2x plus 1. The answer is x minus 5, 2x plus 1. Thank you, Belle. That's correct again. Okay. Amanda, could you please email me? I will email back with the link of the video. Okay. Okay, perfect. So let me let me show you the slide divide slide for this question. I think you guys are doing great. Firstly, slide away and create a new trinomial, x squared minus 9x minus 10, and then shortcut. The 2 integers must multiply to negative 10 plus add to negative 9. So it's negative 10 and 1. Negative 10 and 1 multiply to negative 10, add up to negative 9. And then divided by the original leading coefficient 2. And we have simplified 10 over 2 is 5, x minus 5, x plus half. And then we slide this denominator in front of x. So the final answer is going to be x minus 5 times 2x plus 1. Like that. Right? X minus 5, 2x plus 1. Perfect. Oh, we have one more. Okay, try this one. This one is challenging. Okay, I'll do this one. This one has two variables. Slide divide slide method still work, but we're gonna be more careful, and we need to see y as a constant. Here, we need to see or treat y as a constant. Even it is a variable, but we're gonna treat that variable y as constant, and cx the only variable. So if we cx the only variable, let's sort the trinomial. We have 5x squared plus 12y times x minus plus negative 9y squared. So if we compare this trinomial with ax squared plus bx plus c with the formula, we know a equals 5, b equals 12y, remember we see y as a constant, and c equals negative 9y squared. All right. Since the leading coefficient 5 is not 1, we want to slide and create a new trinomial. The new trinomial would be x squared plus 12yx, and 5 times negative 9y squared is going to be negative 45y squared. Just to try to see this question. If you have trouble to understand or do it on your own, it's totally fine. It is a challenging problem. So we are going to shortcut. We need to find the two integers, multiply to negative 45y squared, and add up to 12y. And they multiply to negative, add up to positive, so they have opposite sign. And the positive number has a bigger absolute value. And we are going to factor 45y squared. 45y squared can be factored as y and 45y, or 3y, 2 doesn't work, 15y. 4 doesn't work, 5y times 9y, 6 doesn't work, 6, 7, 8, 9. So that's all the possibility. And the y is positive, the other is negative. Positive is bigger. So this one doesn't work. They do not add up to 12y. This one works. 15y positive, 15y positive, and negative 3y negative. 15y and negative 3y multiplied to negative 45y squared add up to 12y. So the shortcut would give us x plus 15y, x minus 3y. And then we divide by the original leading coefficient, which is 5. And then we simplify, we have x plus 3y. Here we have x minus 3y over 5. And then we slide back. The final answer is going to be x plus 3y times 5x minus 3y. Let me double check. It's correct. Well, it might confuse someone, but we are not going to spend more time on this question because this question is a challenging question. Even you see that on your test, it's gonna be just a little bit of point. It will not affect your score too much. The important thing is you understand how to do those regular problems. So if you need more help with this question, you can watch the video. It is a challenging problem. does not mean it's important. More important questions are those regular questions. Okay, so we have number 9. We have so far, let's summarize a little bit. So far about factoring a polynomial, we have learned a few methods, right? We have learned factoring out GCF. That actually is the first step whenever we need to factor a polynomial. So always start from observing the polynomial and identify the GCF of all the terms in the polynomial. If the GCF is not 1, even is -1, we need to factor it out. And the second method we learn is called factoring by grouping. We apply factoring by grouping when we need to factor a polynomial with 4 terms, 1, 2, 3, 4 terms. Remember, we cut it in the middle. We group them. We divide them into 2 groups, right? And then we take out the GCF from each group. And then we should see the 2 groups have the common binomial factor, and then we factor the common binomial factor. That's the factoring by grouping. We practice that on Monday. And the third method we learn is called the shortcut method. We apply shortcut method when we need to factor a polynomial. When we factor a quadratic trinomial with the leading coefficient 1. And the fourth method we learn is called the slide divided slide method. We use that method to factor a quadratic trinomial with a leading coefficient different from 1. And that's so far what we have learned. Besides those methods, next thing we need to learn about the factoring polynomials are the special factoring. Some polynomials, they are special. Why they are special? Because we are able to use formulas to factor them. So I would label this part as method number 5, special factoring. We use formulas. We use formulas to factor polynomials. So method number 5. Method number 1, factoring out GCF. Method number 2, factoring by grouping. Method number 3, shortcut. Method number 4, slide divided slide. Method number 5, we are going to learn special factoring. Special factoring is to use formulas to factor some special polynomials. Okay, look at this table. Look at this table. This table has 2 columns. One column is about special factoring, the method we're going to learn, the formulas we're going to learn. And then on the other column, we have a special product. Let's look at the special product formulas. X plus y times x minus y equals x squared minus y squared. X minus y times x squared plus xy plus y squared. Do you think you are familiar with those formulas? Do you remember any of those formulas? We actually learned those formulas in chapter 5. You guys actually helped me to prove those formulas right after we learned the box method. Right after we learned the box method, you guys helped me to prove those formulas. Do you remember those? Any, doesn't ring a bell at all? This one, x plus y and x minus y, they are conjugate. Their multiplication is a difference of 2 squares. Remember I said remembering their names help us to remember those formulas. And this one is square of a binomial sum equals a perfect square trinomial. This is the square of binomial difference. also equals a perfect square trinomial, but the middle term is negative. And this binomial times this trinomial gives us a difference of 2 cubes. And this binomial times this trinomial gives us a sum of 2 cubes. Well, I would show you actually. For proof, we didn't learn that. Let me prove that we covered those formulas in chapter 5. Right after the box method. You see that, number 17? Special product. Remember that? I labeled the names for those special expression, the structure. Yeah, now, okay, very good, thank you. If you don't remember, it's okay, but you need to memorize, you need to remember this chapter. Okay? I would recommend, if you are not familiar with those formula yet, you prove them. For example, you use box method to prove x plus y times x minus y equals x squared minus y squared, and all the 5 formulas. And look at their corresponding special factoring formula. And this formula, simply, I got this formula simply by switching the left side and the right side of this formula. And I did the same thing to all other formulas in the second column. And those formulas are special factoring formula, okay? And let's do one at a time. We do not rush. We only have 20 minutes, so we do one at a time, okay? The first formula, number 1. The first formula, number 1, is x squared minus y squared equals x minus y times x plus y. When do we use this formula? When to use it? We use the formula when we need to factor a binomial whose structure is a difference of 2 squares. We use this formula to factor a difference of 2 squares. If you are going to factor a binomial, of course you have to check the GCF. If the GCF is not 1, you factor out the GCF. And then you look at the structure of the binomial. So if the structure of the binomial is a difference of 2 squares, the first base is x. The second base is y. The binomial is a difference, so that's why we have a minus sign in the middle. Difference of 2 squares. Square of x minus square of y. If you have a polynomial, if you have a binomial whose structure is like that, then we are able to use this formula to factor it. And that's probably the only method we can apply to factor it. Use the formula. And how do we use the formula? The factorization simply equal to the first base minus second base. Multiply with the first base plus the second base. So one factor is the addition of the two bases. The other factor is the difference of the 2 bases. Be careful with the order. It's always the first base minus the second base. I think the best way to learn it is to practice, to use it. But before that, let's practice some numbers here, okay? And I'd like you to include those in your note. Include those in your note. One square, today we're going to do the first table first. The first table, I give you all the common used perfect squares. 1 square is 1, 2 squares is 4, 3 squares is 9, 4 squares is 16, 5 squares is 25, and so on, all the way to 20 square equals 400. My point here is, when you see one of those numbers, you need to know they are special. Why they are special? Because they are perfect squares. For example, when you see 144, you need to know 144 is a perfect square. It is a square of 12. And when you see 361, you need to remember 361 is also a perfect square. It is square of 19. Yeah, please find the time to memorize those perfect squares, okay? That would help us when we need to apply those formulas. Okay, let's practice. Number 20. Special factoring. Factor the polynomials using formulas. And the first question, we have a binomial. We need to factor a binomial. And look at this binomial. It has two terms, right? Of course. In the middle, I have subtraction. And I see x squared and I see 100. 100 is a perfect square. 100 is 10 square. And this binomial has the structure of a difference of two squares. So the first base is x. The second base is 10. Do you see that? First base x squared minus second base 10 squared. So the first binomial is a difference of two squares. Please remember the name is difference of two squares. So by the formula, we are able to factor this difference of two squares as parentheses times parentheses. In the first parentheses, we have the difference of the two bases, the difference of base 1 and base 2, so x minus 10. And in the second parentheses, we're going to have the addition of the two bases, x plus 10. I don't think it's very difficult to memorize because in one parenthesis, you just take a difference of the two bases. In the other parenthesis, you just put in the sum of the two bases, and then you are done. Okay, so try this one, practice. Factor this polynomial. Factor 100 minus x squared. I'll give you a couple minutes. Factor 100 minus x squared. By the way, it's different from x squared minus 100, okay? It's different. This one is 100. Oh, there's a purpose I asked you to do this. 100 times x squared. Please share your answer when you have one. 100 minus x squared. Ten minus x times 10 plus. Awesome. Very good, Amanda. Very good. What's the purpose of including this practice? I want to show you that because I want to show you the order. Because one parentheses, we have the difference, right? The other parentheses, we have addition. So for the addition part, 10 plus x is the same with x plus 10. That's okay. You write x plus 10 or 10 plus x, doesn't matter. But for the other parentheses, you're going to put the difference of two bases. You have to be careful which one minus which one. It has to be the first base minus the second base. Okay, the first base, since this is 10 squared minus x squared, so the first base is 10, and the second base is x. You know, somehow you write x minus 10 is more comfortable. Maybe you feel the same. 10x minus 10 probably more comfortable than 10 minus x. However, in this case, x minus 10 is incorrect. It has to be 10 minus x. It has to be 10 minus x. Because it has to be the first base minus second base. Do you see my point here? There's a reason I want you to practice this. See the difference between the two questions. X squared minus 10 squared, 10 squared minus x squared, they are different, right? Yeah, the order is different. Very good. Thank you. All right, let's look at number 2. Number 2 is a binomial. It's a binomial. Well, when you need to factor a binomial, you should consider or observe the structure to consider if this binomial a difference of two squares. How do we know if the binomial a difference of two squares? You look at the signs, right? Like oh, that's a sign. For example, if the baby crying, then that's a sign that maybe she's hungry or dirty or sleepy, right? So you have to see the sign. I see x squared, y squared, and I see 36. 36 is 6 squared. And for 49, and I see 49. 49 is 7 squared. So those are good signs. Signal this might be or probably is a difference of two squares, right? So let's dig further. Look at it further. How do we really sure it is a difference of two squares? And 36 x squared is 6 squared times x squared. And it is 6 times 6 times x. And we can switch the order. 6x together, another 6x together. So it's 6x to the power 2. Do you agree? Turns out 36x squared is 6x to the power 2, or square of 6x. Square of 6x. Let me erase other things. And then we look at the 49y squared. Do not worry about the sign in front of that, okay? In this case, you're going to see 49y squared as a term. And the subtraction is really a subtraction. So 49y squared. 49 is 7 squared. 7 squared is 7 times 7. Y squared is y times y. And we can rearrange the order. 7y times 7y. And that gives us 7y to the power 2. Okay? It is a difference of two squares, as you can see. It is a difference of two squares, a minus sign in the middle. And the first term is the square of 6x. So the first base is 6x. Second base is 7y. Well, I want you please see or agree this is a difference of two squares. And the first base is 6x. Second base is 7y. and help me to apply the formula to find the factorization. If you agree, if you see it is a difference of 2 squares with the first base 6x, second base is 7y, I would recommend you do the same thing, guys. On your scratch paper, do the same thing. Write down the first base and the second base. And what's the factorization? Are you guys still there? What's the formula says? I'm still recording. What's the answer of this question? If we have a square of 6x minus square of 7y. Very good, very good. Thank you, Amanda. Perfect. So the answer is gonna be 6x first base minus second base times first base plus second base, right? Do you see that? The base would be different for each question, for different question, but the pattern is the same. If we have a difference of 2 squares, identify the first base and the second base, and the result is always equal to base 1 minus base 2 multiplied by base 1 plus base 2. Okay, guys, you try number 3. 1 minus 4y squared. Try factor 1 minus 4y squared. Is 1 a perfect square? And how do we write the second term as a square, perfect square? And we have 4y squared. 4 is 2 square. 2 square is 2 times 2. Y squared is y times y. You can write 2y times 2y. And please share your answer in the chat. What's the first base? What's the second base? Awesome. Very good. Perfect. Both Joe's answer and Amanda's answer are correct. What about other students? Do you have any questions? Are you grasping the formula? Structure. See the pattern, see the structure. Do you have any other questions about the first formula, difference of two squares? And if not, we're gonna stop here and continue on Monday. If you have any questions, please feel free to email me. I'll say good night now. See you on Monday. Yes, just practice. Good night, Felina.